Congratulations, you guys are now starting calculus. I want to start today with a little bit of a change. The book, we used to just dive right into the calculus book and call this chapter 1 of calculus. I'm going to keep it. Your pre-calc book was good and it had a lot of stuff. I like its organization a little bit better than chapter 1 of your calc book, so we're just going to go with that, which required a little bit of restructuring, but it's there, and all that's done and finished. For you guys, I'm going to spend a lot of time on this first graph, a lot of time on it. And I need you to take a little bit of a humble sense of why I might be spending a lot of time with this graph and what we can piece together from it. So take a second, read, scan through, and look at what you can tell and what you can determine from this graph. For one, look at the sentence right above it and look for any inconsistency that you see in the sentence with how the graph is depicted below. Do you see one? Cool.
It says it's on the interval -12 to 12, but there's arrows on it.
There are. Given that the graph itself doesn't extend from -12 to 12 on the x-axis, which of the two of those should override the other?
Closed interval overrides there.
Yeah. We're going to go with the closed interval. So just sketch out a little bit here and mentally be aware that that actually can happen quite frequently in some of the problems that you're going to encounter. That you have a graph with a limited view shown, but it's going to be a closed interval, which means that there are no points depicted, or whether there or not, left or right. I also want you to look at the graph and have a sense of which of those pieces in this clearly piecewise function, which pieces would you be able to determine the equation for, and which ones would you probably not? How many pieces do you see that you definitely can determine the equation for? Yeah, the three linear ones. But the other ones you really wouldn't be expected to know an equation for, not without further information. There's no guesstimating of points that will be present. There's nothing of that kind. Okay. Let's talk a little bit about what we can see about end behavior. End behavior was a term that you guys used to mean as you moved infinitely far left and right. Well, it's a little bit tricky because there is no end behavior, right? We're at limited intervals. So we don't necessarily have to worry about that left to right. Again, we're only going from -12 to 12. Do you see any breaks left to right where the points don't exist? Whoa. We always refer to x values. So what x values do points not exist? 9.
-6.
-10. -6. Yeah. And that's another good point here. So you can see at x equals 9, it depicts a vertical asymptote. I would argue that it's implied there is also a vertical asymptote at x is equal to -10, even though it's not directly depicted. And it should be, because if they intended that to connect, you would have to show that to assume that. And it's probably not going to connect. You can see from an element that we're going to refer to as concavity that this is continuing down without a certain curving change happening. So I would say there's definitely a vertical asymptote at x is equal to -10, and you guys can depict that as well. So all of those come into play before we even talk about limits. And this is some of what I would call a little bit of graphical literacy. Being able to read a graph and see pieces and see all this stuff happening. Okay, the concept here we're going to talk about is limit. And this is the most fundamental concept in all of calculus. Ergo, it's the first chapter of calculus. You can't do anything with calculus without talking about limits. Which means we are oftentimes going to be less concerned about what is happening at a point and more concerned about what is happening in the neighborhood of a point. Now, oftentimes that's going to be exactly the same thing, but sometimes it won't be. And that's the distinction we have to make here. This is what limits are going to let us do. We're going to be able to go to infinity. We're going to be able to divide by 0. Shh, don't tell. We're going to be able to do things that you guys have not been able to do before. We'll be able to take the slope of a single point. We'll be able to actually count an infinite or add up an infinite number of things. You kind of did that a little bit when you were freshmen, and we did a limit, we did a limit of this infinite sequence, infinite geometric sequence summations that added up to become a single number. But let's look at the number 1 and see what this is actually asking. The limit as x approaches negative 6. What I'm really saying is this, which I'll write up above. As x approaches negative 6, what does y approach? Which means that as x gets infinitely close to negative 6, what does y approach? Before you guys raise your hand and see what's happening here, I want to get a visual that actually applies to something your calculator does when it calculates points as well. It does this by limits. Your calculator, you've seen it give a left bound and a right bound when you try to find zeros. You've seen that as like depicting. And the closer you get, the easier burden you put on the calculator in actually finding your work. But that's very similar to what a limit does. As these bars are getting closer and closer and closer to negative 6, what is y getting closer to?
0.
Okay. This is x equals negative 6. But as this happens, y, and I want you to see this as a targeting effect happening. So we'll try to animate this if I can, and it doesn't flip out at me and try to move to a different page. And I know, I'm using a lot of the memory here, a lot of the internal RAM. But let's do this. Nope, it's not going to let me select right now. It's like, no, you're running too many things at the moment, connected and recording, and yeah. But basically, as that shrinks down and gets smaller, you see how it's targeting a single place. It's not a point that it's targeting, it's a location. There is no point there, but that's not the point. The idea is that as x approaches negative 6, y approaches what? You can say it, even though it's disconnected, 0. So write that down for the limit of x approaching negative 6. As x approaches negative 6, y approaches 0. And I told you we're going to be spending a lot of time on this graph. And while we're reconnecting, I'm going to try this as well. As x approaches negative 6, y approaches 0, which means that the limit as x approaches negative 6 of f of x is 0. Come on, you can do it. You can do it. This might be my reason I asked JD to give me a 16 gig. Resume. As x approaches negative 10, what is y doing? Okay, that is a very acceptable and a better way to describe it, but I do want you to know, kind of from a standpoint of what we were doing up here, what is actually happening. As x is targeting negative 10, y, it's actually not approaching a single point at all. So it's sort of a weird question to describe what is the limit, and you tell me, though there is no limit, it's negative infinity. So the limit is the unlimited limit on the negative side. You see the sort of backwards logic you're kind of giving me here? Negative infinity is correct, and I will take it, and I will actually prefer it. But I want you to know that that's a subset of saying what Caddy was famous for saying, that the limit does not exist. It's a subset of saying that. There is no limit. We are actually, in essence, describing what the graph is doing, and you're giving a more specific answer than saying the limit does not exist. It doesn't exist. Not only does it not exist, it blows up both sides approaching negative infinity. So know that that's what you mean, but also know that this is a style or a type of does not exist. There are two other types of does not exist. One of them would be positive infinity or just infinity, and the other would be what's happening right here, where as we approach 9, you can't really say whether it's positive or negative infinity. So for that, we do say does not exist, which now that we say does not exist means a split like this. So does not exist means this, positive infinity means this, negative infinity means down. What is f of negative 3? This is a different question. Yeah, f of negative 3 is negative 3. On this graph, we're referring to the location, the actual ordered pair of negative 3, negative 3. What is the limit as x approaches negative 3 of f of x? Where basically I'm asking, what is y getting really close to as x gets really close to negative 3? What do you think that is? It is also negative 3. It is very common, obviously, for the limit and the ordered pair to be the same thing. So that is a case where not only is the limit negative 3, the value is negative 3. So we're going to refer to this as the limit, and we're going to refer to this as the function value. And we'll be shorthanding by saying those a few times. Now let's compare another set, and you can probably tell that 5 and 6 go together. What is f of 2? What is the limit as x approaches 2 of f of x? There's a couple ways you can take that. Now be careful, because as x approaches 2 from both sides, and as this starts to come closer and closer and closer together, what is y becoming? So what you're telling me, well, but so is this right here. And we still answered that limit. A limit is not what's happening at the point. Ignore any holes, ignore any closed circles. A limit's not what's happening there, it's what's happening as you get close to there. So as you get close to x equals 2, what's happening? Okay, so you're giving me two different answers. We need a limit if there's going to be a limit. 1. But I'm definitely not getting close to 1, because that's not even, this is not getting close to 1, this is not getting close to 1. Can't average the two of them and say that it's a limit. So something's going on here. Now, I will tell you that there is something called a one-sided limit that we'll be dealing with in the coming days, where I say that the limit as we approach 2 from the right it is 4, and from the left it is negative 3. But if the limit from the left does not equal the limit from the right, then, Caddy, we say the limit does not exist. If you have not seen the Lindsay Lohan classic film Mean Girls, you must. She's the queen of beasts. I'm glad. This is not the only time we'll bring it up. Let's talk about 5. I'm asking you two questions. I'm asking you for the limit and then the function value. What is happening at x equals 5? Ooh. Well, because the limit is x approaches 5. Yeah, you're right. It's the approach. Thank you, Simba. Okay. I'm going to tell you this. If you guys guess on this, I will hurt you. I will harm. You do. Let's be a little methodical on this. We all learn this, that if we're not sure, we know that this is the ordered pair 2, 4. This is the ordered pair 7, 0. So an equation of this would be y minus 0 is equal to 4 minus 0 over 2 minus 7, so negative 4/5 x minus 7. And I'm going to plug in 5 in for x to get y of 5. Probably should put f of 5 is equal to negative 4/5 times 5 minus 7, or 8/5. Do not guess on ordered pairs dead smack in the middle of two linear points that you could actually figure out. You could do this. So 8/5. Yes, you are, Jess. And what's f of 5? 8/5. And finally, the limit as x approaches 9 we just talked about does not exist. Now, yep.
Could you explain how on number 2 does not exist and infinity both suffice?
On number 2. You mean as x approaches negative 10?
Yeah.
Sure. There is no limit in that this at negative 10 we're not approaching a point. So a limit itself is defined as a barrier. It's a point that you never cross. There is no barrier. So to say that the limit is the unlimited negative infinity is kind of a thing. And yet we'll still use that to describe it because it gives a more specific answer than just saying does not exist.
But 9 doesn't work because the NBA rules don't match.
Yes. So when you actually say does not exist, you're giving a little bit more information if you allow for the possibility that you're going to say positive or negative infinity. Okay, finally, for what values of C does the limit not exist? Let's do this in interval notation. What values? Give me them. Negative 10. 2. And 9. Ready for this? How about 12 to infinity? And how about negative infinity to 12, areas where the graph doesn't exist? Now, I'm going to argue there is a limit at 12 on both sides. We'll again talk about that in the coming days. But the reason I'm going to put a limit there is because when it's the end of an interval, we still say that there's a limit at that. Even if it's one-sided, it doesn't do much service to talk about a limit at an endpoint unless you talk about one side. But that's a nitty-gritty thing. The majority of what I want you to depict is right here. And most of the time I would ask this question for what values of C on the closed interval. Still, I didn't say on the closed interval, so this is a period 7-6 from period 2. They won't get that. Ready to learn something on your calculator you did not know how to do? We discovered all this morning, thus truly necessitating my re-recording here. This is a section that Mr. Franklin convinced me I really needed to do. He says it really helps you understand the concept of limits more than anything else. So I have 5 problems here. We're probably not going to do all 5 of these right now. What time are we out of here? 36. Thank you. We may. But what I want you to do is graph this into the graph part. So I'm going to go to menu, graph, tab. This is the part where I have to pray that this thing works. Come on, give me my keyboard. Okay, x to the 4th minus 16 over what? Thank you. Yay. I actually care a little bit less about the graph the way it looks right now. I don't. You could zoom out and get a better looking graph, but the question is asking for the limit as x approaches negative 2. So I want to get my graph visual in the neighborhood of negative 2. So I'm going to make this from negative 4. I'm going to maybe make this 1, maybe make this 4. Let's make this negative 10. Let's try to make that negative 10 again. Let's see. Do you guys remember you can click or double click on any of these values that you're trying to change and press tab to cycle through them? So you don't have to ever leave that. You can even take the label and right click on it to hide it if you don't want that there. Do you know how to right click? Control menu. Good. So this gives me all of this. Now, both calculators include a table function. I think yours are on the top keys, and there's a little table option to start seeing a table of values. Table set means like what you're actually setting your thing to, which we're going to have to do here in a second anyway. There should be an option to view a table of values. For you guys, you're going to hit menu and go to table. And we're going to go to a split screen table. Or you can press Control T. And we get a split screen. And I want to figure out where negative 2 is. So I'm going to tap the up key and just keep going up until I get a negative 2. It says hashtag error undefined, but we can do better. I don't want, if I'm trying to figure out what's happening in the neighborhood of x equals negative 2, okay, that means you graphed something wrong. Okay. Hey guys, let's say that I want to do a little bit better and I want to get in the neighborhood of negative 2. Well, negative 3 and negative 1 are not in the neighborhood of negative 2. They're not. And I know it says undefined, but clearly when x equals negative 2, I can see a continuity happening. Or see, not the continuity, I should say. I can see it probably is not graphing the hole, but there is a hole there. I want to know what value that hole is. And to do that, I need this negative 1, I need to get closer. You guys can thank Allison Caffrey for figuring this one out very quickly. She pressed menu and went to table and then went to Edit Table Settings. We found that within about 20 seconds. And changed the table step from 1.0. We're going to get really close. Let's do 0.01, which means that it's graphing every 1/100th. Now I'm going to go down, and we need to get down to -2. I know. Re-recording now is connected. Eventually you get down to here. What do you see for the possible value of the limit at x equals -2? No. What's it skipping?
Right. Oh, I got the right now.
Yeah. And if you weren't sure about that, then change your table settings to menu, table settings. That's going to be fun to get down to. Yeah, but you're going to be scrolling for a while. Not too long. Oop. There. This should be somewhat more obvious about what value you're probably skipping over. And not to spoiler alert, but the majority, if not all of these on this sheet, are going to be values that you can easily spot. So this is the table setting value, and this is crucial to understanding how limits work, because there is no value at x equals -2, but what you're determining is what's happening as you get infinitely close to -2. As x approaches -2, y is getting infinitely close to -8. So I'm going to pray this works while I'm connected to AirPods and recording and connected to the screen. Please don't bug out on me. We're going to snip this so I can paste this in the document. Yes, you can. Oh, I'm going to go set picture as background so I can paste it right on here. You can do it. And shrink it. Oh, this is working. Yay. Has anyone gone and done the second one yet? Got it. So the limit is -8. You really can't put much of anything except -8. And there's not a lot that you guys can do here. I'm not asking you to take screenshots of this, and I know that you guys could just copy an answer key down on this. I'm asking you, take the time to learn the ins and outs of your calculator and the tricky nuances that happen, so that when you hit a quiz or test, you're not pressed for time and trying to learn all this stuff in the middle of a quiz or test. Okay. Yes. Oh, yes. So I'm going to go insert a new graph. I'll keep the other one going. And let's just do the second one, and then we'll call it a day on those and skip to the last page. Nope. Control radical. Adam, can you read it to me?
2x plus 1 or 2x minus.
Okay. And it wants the limit as x approaches what?
1,
Just 1.
All these are undefined.
Okay. So as x approaches 1, we're going to go menu, table, split screen table. Oh, I get 1.73. When you get 1.73, you may realize that I could have actually gotten that by doing what? Plug it in. If I plug in 1, if it's a point where there's no hole, that means that this was equal to f of 1. So I go radical 3 over 1, which is radical 3. And in fact, when I look at the graph again, you can do it 1.73, that is radical 3. So, yay. Yeah. If you just see that it's not undefined, go ahead and plug it in and see what's happening. It's not too. I'm not giving you ones that are too difficult beyond just like a 2-second plug-in, but I want to see that that's what you can do. Again, what time are we out of here? Okay. Then I'll snip this in a minute, and let's go to the last one. Bye. Consider the piecewise function below. you're going to graph this on this graph. This should take all of about 12 seconds to do. Remember, you're graphing this as a single ordered pair, 2, 3. And then whenever x is not 2, you're going to lose that from me. Whenever x is not 2, you graph 3x minus 2. I may or may not be able to reconnect in time, but I think you guys can graph 3x minus 2. I really hope you can. Remember, you're putting a hole at x equals 2, so you should have a y-intercept at negative 2, up 3 over 1, hole at 2, 4.
You can just plug in all of these.
Now, can you answer the questions about it? There are only 2 questions it asked. What is the limit as x approaches 0? So look at the graph and answer that question. What's the limit as x approaches 0? Yeah, negative 2. As x approaches 0, y approaches negative 2. But careful, there is a limit here. As x approaches 2, last point, guys. As x approaches 2, what is y getting really close to? Is it 3 or is it 4? In the neighborhood of what's happening, remember neighborhood, it looks like it's approaching 4. This was not a predictable jump. The prediction that would happen as you're approaching from either end is that you would approach 4. So the limit is 4. Okay. You guys are a good audience. I will put this up. And I will, hang on, let me pause, stop the video.